So a classic problem in machine learning is the existence of multicollinearity in your dataset. And what is multicollinearity? It occurs when there is a high correlation between the independent variables in the regression analysis, which impacts the overall interpretation of the results. It reduces the power of coefficients and weakens the statistical measure to trust the p-values to identify the significant independent variables. Hence, we would not be able to examine the individual explanation of the independent variables on the dependent variables. Hence, overall multicollinearity is one of the main assumptions that need to be ruled out to get a better estimation of any regression model. So the problem of multicollinearity can be divided into these three parts broadly. First, it would be hard for you to choose a list of significant variables for the model if the model gives you different results every time. Then coefficient estimates would not be stable and it would be hard for you to interpret the model. In other words, you cannot tell the scale of changes to the output if one of your predicting factors changes by 1 unit always. And thirdly, the unstable nature of the model may cause overfitting. If you apply the model to another sample of data, the accuracy will drop significantly compared to the accuracy of your training dataset. So, depending on the situation, it may not be a problem for your model if only slight or moderate collinearity issues occurs. However, it is strongly advised to solve the issue if severe collinearity issue exists. For example, a correlation of more than 0.8 between two variables, or the variance inflation factor, that is a VIF factor, is more than 20. Now, also a quick point, when not fixing multicollinearity is kind of okay. So this situation depends on the primary goal of the regression model or the project that you are doing. So the degree of multicollinearity greatly impacts the p-values and coefficients, but not predictions and goodness of fit test. So, if your goal is to perform the prediction and not necessarily to understand the significance of the independent variables, then it is not mandatory to fix the multicollinearity issue. And now quickly, Python code implementation of for checking the multicollinearity in your training data frame. Oh, this is a markdown cell. Let me change it to code cell. Yes. So what I'm doing is mainly I'm importing this library. This is the most common library you will see when dealing with multicollinearity. And it comes from the stats model package. And this is their official documentation. So what they're saying that I'm looking at these variance inflation factor, VIF, this documentation here. And what they are saying, the variance inflation factor is a measure of the increase of the variance of the parameter estimates if an additional variable given by XORG IDX is added to the linear regression. It is a measure of multicollinearity for the design metrics. Then one recommendation is that VIF is greater than 5. If VIF is greater than 5, then the explanatory variable given by XORG IDX is highly collinear with other explanatory variable, and the parameter estimates will have large standard errors because of this. Okay, now let's go back to my code. So this is the import, and normally what I do is I have a quick check VIF utility method here like this, which implements this variance inflation factor module and checks the score from these variance VIF for each of my features from the data frame. So what I'm doing in this utility method here, X is the only argument to this method, and that actually is my data frame or the training data set. And then I am having these VIF features which is equal to x.columns, and then I am calculating the actual score with this line. With this line. So this will produce a list of all the values where it will and the looping through will be through the range of x dot shape 1. So each of my feature values will have its variance inflation factor appended to this list. And finally, then I'm just sorting the feature values by their VIF score and returning that returning that data frame, that is, which will have all the features and their scores. And finally, I'm implementing this, invoking this method check VIF on my X trained dataset, and what I will get is something like this. So this is the return dataset from that check VIF utility method, and I can see the VIF scores are given for each of the features. All right, that pretty much wraps up this video. If you have liked this one, smash the like button. And also do subscribe, because I'm going to do many interesting NLP projects over the coming days and weeks. So see you in the next one. Thank you very much for watching.